Today we're going to be going over how to use Kirchhoff's voltage law to find the current going through a circuit. What we want to do first is label the potentials of each of the components. For this 10-volt source, the longer bar here indicates the positive terminal of the source, where this smaller bar indicates the negative terminal of the source. Now, current in a circuit goes from high to low, so the voltage here will be 10, indicated by the voltage source, whereas this is ground, this indicates that there is 0 volts in this section of the circuit. So the current is going to go from the high voltage here of 10 volts down to the low voltage of 0 volts. So that means that the potentials across the resistors will go from high to low. And the same here, high to low. With all of the potentials labeled, you can now use KVL to find the voltage drops across each of the components. Now, starting from ground, we can go up and we run into a negative sign here. So this indicates that the sign of our first part of the equation is going to be negative. So we have a negative 10 voltage drop across this component. As we keep traveling up and around, we run into our second component, which is a 3 ohm resistor. There is a positive sign here, so we can add a plus right here. Now, as seen here, using Ohm's law, we can find the voltage drop across this resistor by using the current through the resistor and the amount of resistance that that resistor has. So we have a resistance of 3 ohms, so we can write that down. And the current going through here, we can label it I1. So I1 will go that way, and then it will go down. So 3 times I1 is going to give us the voltage drop across this resistor. Continuing through the circuit, we have another resistor here, a 2 ohm resistor. Again, we run into a positive sign, so we can add a plus. Now, V equals I times R, so R will be 2, and I we will call I1. So that is all of the components within our circuit, aside from ground, but ground just indicates where our 0 voltage is. So we can set all of this equal to 0. Now we can easily solve for I1. Doing so, we can add the like terms, giving us 5I1, and setting that equal to 10. With some simple division, we find that I1 is equal to 2 amps, and that is how you find the current through a simple circuit, such as this one using KVL.